Welcome back as we continue our wonderful journey in core mathematics. My name is Nanaya Wedu, and you can call me Sir Nana. Remember to like this video, share this video, and comment at the comment section. And remember that you would click on the notification bell and subscribe to my YouTube channel so that you can be abreast with all videos that I put out here. In our previous lesson, we've considered an example of how we can find a Mach letter where we have the sum of interior angle. In this lesson, we want to begin by looking at the Pythagorean theorem. Now, let's consider the Pythagorean theorem. So when we look at the Pythagorean theorem, basically when we have a right angle triangle, and we know a right angle triangle as a triangle that has a 90 degrees on a side, right? There are some special properties or special geometric properties, and there's a relationship that exists between this right angle triangle, and that brings us to that Pythagorean theorem. So that relationship is that if we have the square of the longest side, which is called the hypotenuse, let's label it as C. So if you have the square of the longest side, which we call the hypotenuse, right, it is equal to the sum of the square of the other two sides. So let's label them as A and B. So we can say that C squared is equal to A squared plus B squared. So this is basically the Pythagorean theorem. And as we mentioned, it only comes out of the special geometric properties that exists when we have a right angle triangle, right? Or the relationship that exists between the sides of a right angle triangle. Now let's look at how we can verify the Pythagorean theorem. So let's consider this diagram very carefully. So when we look at the diagram, we see a right angle triangle which have been drawn, right? So we have a right angle triangle, and on the sides of the right angle triangle are squares, right? So on the side here, we have the A here, right? So let's assume that that A exists here because the triangle has been turned. So we have our 90 degrees here. And then on the other side, we have our B, right? And that side also has a square. And then on the longest side, which is the hypotenuse, we have our C, right? So the C represents a hypotenuse, which is the longest side. And then our A and our B represents the other opposite sides of the right angle triangle. Now let's consider the square of A, right? The square of A also deals with the area of the square at the top here, where we consider this square here, the area. Now we can count the number of boxes to be able to know that. So we can say that it has 1, it has 2, it has 3, it has 4, it has 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So that implies that for our A, it has 16 boxes. So A squared is equal to 16. Now when we consider our B, we realize that the B also has 1, 2, 3, 4, 5, 6, 7, 8, 9. So our B squared will be equal to 9 in terms of the number of square grids, right? And then when we consider our C, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We have 21, 22, 23, 24, 25, right? So our C squared is equal to 25. So let's look at the Pythagorean theorem and see whether it satisfies what we have just looked at. So we know that for Pythagoras theorem, the square of the longest side, which is the hypotenuse, C squared, is equal to the sum of the squares of the opposite sides, which is A squared plus B squared. Now let's consider them in terms of the real values. So we know our C squared is equal to 25, right? Our C squared is equal to 25, so we have 25. Then we say it's equal to our a squared is 16 and our b squared is 9. Now what is 16 plus 9? We see that our 25 will be equal to 25. Hence, we can say that we've been able to verify that if you have c squared, provided it's a right angle triangle, if you have c squared, it's equal to a squared plus b squared. And this represents our Pythagorean theorem, right? So now basically when we consider the Pythagorean theorem, we are looking at having a right angle triangle, and we know for a right angle triangle there's a 90-degree angle at the side. And once we have that, we know that the square of the hypotenuse is equal to the sum of the squares of the opposite side. So a squared plus b squared. Let's assume we've labeled this as a, b, and c. Then it means that we can write that ac squared will be equal to ab squared as a length plus bc squared. So remember that the Pythagorean theorem says that the square of the hypotenuse is equal to the sum of the squares of the other opposite sides. So basically in this lesson, we have considered the Pythagorean theorem and we've looked at how we can verify the Pythagorean theorem. In our next lesson, we want to consider some examples of questions on the Pythagorean theorem. Remember to share this video, like this video, click on the notification bell, and subscribe to my YouTube channel. See you in the next lesson.